Hello there everyone and welcome to how to make a small Terraria modding series where I'll be covering certain topics that are not really covered in the how to create basic stuff series. So with this first episode I'm doing something that's been requested quite a bit, and that is spinning weapons. That was a really odd way of saying that. And this can be similar to Sky Dragon's Fury and those weapons. In fact, the AI has been adapted from that code. So we're going to be writing this all out. We've got a spinning weapon and we got the item and the projectile we're going to create. So what we're going to do is set up the using directives. So using Terraria, using Terraria.modloader, using Terraria.id, using Microsoft.xna.framework, using Microsoft.xna.framework.graphics, using system. So because I'm going to do the item and the projectile in the same file, like this, it'll be easier to code, and it uses both of these. This isn't normally a way you should do this. You should always try and keep stuff separate. So for the item, we can do public override set defaults. I'm going to set the hitbox of the item, the damage range of the item, let's do 6F, the use time, and animation equals 30. And now these ones are important. .no melee equals true. Item.no use graphic equals true because we use the projectile instead. Item.channel equals true because it uses the mouse being held down. Item.auto reuse also true, as we as the code has you stop using the item and then it restarts. Item.use style equals item use style ID dot holding out. Item dot shoot speed equals 25F, and item dot shoot equals mod content dot projectile type of spinning weapon projectile. That's pretty much everything you need for these set defaults. So let's do public override can use item. Hang on, can't see this very well. Need to move that so I can see a bit better. Okay, can use item return player dot owned projectile counts of item.shoot is less than 1, because we only want one of these spinning weapons to be on screen at a time. In fact, I have a few bloopers from where I was testing some of the code before, and I'll show those at the end of the video. They are quite interesting. So that's everything you need for the item. So we're going to move on to the projectile itself. So once more, override set defaults. Projectile dot width equals 80. Projectile dot height equals 80. Projectile dot penetrate equals -1. This will make it so the projectile will not be destroyed upon hitting an enemy. Projectile dot tile collide equals false. Projectile dot ignore water equals true. Basically these don't get destroyed when they hit those. projectile.melee equals true. And projectile.friendly equals true. So now we're going to write some AI for this. Public override AI. Now I'm going to be using variables that are named like num and num2 or flag or value. It's just because I cannot think of a better name for these. Remember, this is adapted from the actual code used by Terraria's AI. So the first thing we're going to do is float num equals 50f and float num2 equals 2f. I believe this counts for time for rotation, and this is, I can't actually remember where this is used, but we'll get to it soon. Float quarter pi equals minus float math dot pi divided by 4f. So pi is 3.1415 so on. We divide that by 4 to get a quarter of pi, but we want the negative value of it. This is basically negative quarter pi. Now this value here of scale factor is mostly used for dust generation, so I'm going to have that on a separate line. Now we're going to get the player. So player equals main.player of projectile.owner. Now we have the player. I'm going to create a vector 2 of relative point equals player dot rotated relative point player dot mouse interface. I think I need to just go over to my code. Sorry, I made a mistake. That's completely wrong. Dot mounted center. There we go. Sorry, that was a real stupid mistake. We're going to destroy the projectile if the player is dead. So we do projectile.kill return. We're going to add a bit of lighting, similar to how the Skydragon's View does it. So do lighting dot add light player dot center, and we're going to pass in. It's going to be this color. I'm not sure what it would be. It's high in red. Green is fairly low. Blue is fairly low. So it's going to be a more dark red, purplish color. Now we're going to get the sine value of our velocity. So this will return I believe it would be either -1 or 1 in this case. I don't think it's ever popped up at 0, but it'll get -1, 0, or 1. Then we can do projectile dot velocity equals a new vector 2 of sine 0f. So this will be a velocity of -1x minus 0x. Don't know why I said -0, or plus 1x with a y velocity of 0, so it will always remain flat. So now we're going to do some checks for AI. We're going to set the rotation at the start of the AI. We can do projectile dot rotation equals a new vector 2, and I'll just scroll up so you can see a bit better, of sine, and I need to just there we go, that should be better. Sine 0f minus player dot grav direction or dire dot to rotation plus quarter pi plus float math dot pi. needs to be a capital I. Then if projectile.velocity.x is less than 0, projectile.rotation minus equals float math.pi divided by 2f. So now what I'm going to do is show you in game what this looks like. Let me build and reload this. I'll also make this screen a bit bigger if I can. Allow you to see it. I'm going to use my Varian code. Let's set this to noon. I'll also pause the timer. So now, this is what the AI does right now. It's just shot the projectile forwards, and because it's going -1, I'm going to keep heading this way. Let's save and exit, and let's move that back down like so. So now we're going to have to write a bit more code in order to make it rotate and make it set to the position. So what we're going to do now is increase the AI value. Projectile.ai of 0 plus equals 1f. And now for making it rotate, we're going to do projectile.rotation plus equals float math.pi multiplied by 2f multiplied by num2 divided by num. So that is 2 divided by 50 multiplied by float sine. This will just make it either stay at plus or minus or just no rotation at all, which shouldn't really ever happen. And we're going to create a ball. Is done equals projectile.ai of 0 equals 50 divided by 2f. Also going to just move these onto separate lines. So now we're going to check if the projectile has reached 50 or is done and player.control use items. Basically, if they're no longer channeling the item, we're going to do projectile.kill, and then we're going to do player.reuse delay equals 2. So this will make it so the projectile is destroyed if we have reached 50 and above, or if we are done and the player is no longer got the left mouse button down. Else if is done. So if we are done but the player is still holding down and this value hasn't been reached, we are going to just change the direction of the player if we need to. So vector to mouse world equals main dot mouse world. Let's scroll down a bit. Int direction equals player dot direction to mouse world dot x is greater than 0f. Then we put in 1 or -1. This is basically if player dot direction dot to mouse world dot x is greater than 0. If it is, we set to 1. If not, we set to -1. If float dia is not equal to projectile.velocity.x, so if our velocity.x is 1 and our direction is -1, we do player.change dia, so this change direction, projectile.velocity equals new vector 2 of dia 0f. So like before, we're changing the x value but keeping the y value at 0. Projectile.net update equals true. So we'll update the projectile for the network side, and finally we change the projectile rotation to be negative pi, or we minus equal pi, I guess. So now that bit's done, let's see what happens. Once more, I'll bring up that mod sources, build and reload. Single player. Okay. So now you can see it spins, but it flies off in one direction. And once the animation is finished or has reached a number based on our mouse position, we change direction. So it's still not perfect, but we'll get there. Let's once more head back to our code. And now we're going to handle some position stuff. We're going to place this at the bottom. Projectile.position equals relative point minus projectile.size divided by 2f. Projectile.position plus equals... Oh, hang on. No, I've missed something out. Where have I missed? Aha. We missed out this bit. So float rotation value equals projectile.rotation minus float math.pi divided by 4f multiplied by float sine. Also, we're about to do some dust code, but I'm going to skip over that for the time being. So position vector equals rotation value plus a bracket sine is equal to -1. If it is, float math.pi or 0f dot to rotation vector and why does it look like there's a mistake in the code? No, dot to rotation vector multiplied by scale factor. Now we have that, I'm going to skip over the dust code and we're going to write the position variable. So projectile.position equals relative point minus projectile.size divided by 2f. Projectile.position plus equals position vector. Projectile.right direction equals projectile.direction. Projectile.time left dot time left equals 2. And we're also going to update the player dot change dot projectile dot direction. Player dot held projectile equals projectile dot who am I. Player dot item time equals 2. Player dot item animation equals 2. Player dot item rotation equals math helper dot wrap angle projectile rotation. There we go. So now let's once more bring up... Oh yeah. And now you can see that it's spinning, it's staying in position, but there's still a few issues. And this might be fixed with dust stuff, because I didn't actually test dust stuff after. Like I said, I just adapted the code. But we're spinning at a point down here. I mean, you can have it there if you want, but in my example, it's more in the middle. So once more, we return to our code. Now just above here, we can write some dust code. Hang on, I think I've just worked out where we made the mistake. Yeah, it's here. I missed out a line. So instead of multiply by scale factor, we do multiply by this, then that. So that will fix it. So if I just quickly jump over here, I'm not going to increase the size. Just want to make sure that this is now in the middle. More or less. Okay. So I think this will help get it more in the center. So I don't remember how big I made my graphics for this. Trying to find it. Should be here. 96. That will be 48. Okay, so back down here, let's create some dust. So this is going to be at the ends of the spinning blade. Let's do vector 2 dust vector 1 equals projectile.center plus rotation value plus open brackets sine equals -1. If it is, we do float math.pi or 0f dot 2 rotation vector multiplied by 30f. So you may notice that quite a bit of this code looks very similar to this. We've got this whole rotation value plus sine blah 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 dot 2 rotation vector. And that's the exact same as here. Vector 2 dust position equals rotation value dot 2 rotation vector. Then vector 2 dust vector 2 equals dust position dot rotated by float math.pi divided by 2f, so half pi, multiplied by projectile dot right direction. Okay, now we're going to spawn some dust. If main dot rand dot next 2 equals 0, dust equals dust dot new dust direct dust vector 1 minus new vector 2 5f. Then we're doing a speed x and a height and width of 10 and 10. Dust ID, we use 5 for this, just a bit visible. Player dot velocity dot x, player dot velocity dot y, and finally we're going to set the alpha to 150. Then dust dot velocity equals projectile dot direction 2 dust dot position multiplied by 0.1f plus dust dot velocity multiplied by 0.1f. So let's show you what this dust looks like right now. Let's increase this again. Single player, varying world. As you can see, there's some dust particles coming out just around where the blade is, and they're falling down. And see, this might be better in the dark, so let's just change the time to night. And you can also see the lighting as well. Okay, now let's add a bit more dust coming out at the blade tops. Let's make this slightly smaller. Okay, so now after this if statement, we're going to do a for loop. So for int I equals 0, I is less than, and we can do for I plus plus. Now we're going to be setting a few scale factors. This is going to position the projectiles based on certain values. So float scale factor 2 equals 1f. Float scale factor 3 equals 1f. Switch I, case 1. We're going to change scale factor 3 to be minus 1f. Case 2, scale factor 2, going to set to 0.5f, and scale factor 3 equals 1.25f. Case 3, scale factor 2 equals 0.5f again, scale factor 3 equals minus 1.25f. And we don't have to do case 0 because that will be the default here. So now, after this switch, we want to do if main.rand.next of 6 is not equal to 0. So every 5 out of 6 times this will happen. So dust2 equals dust.new. Let me scroll up. Dust direct. Projectile.position 0 0. Dust ID will do fire again. 0f 0f 100 for alpha. Dust2.position equals projectile.center plus dust position multiplied by 60f plus main.rand.next float multiplied by 20f. Then we multiply this by scale factor 3. Dust2.velocity equals dust vector 2 multiplied by 4f plus 4f multiplied by main.rand.next float. Close that, and then multiplied by scale factor 3 multiplied by scale factor 2. Dust2 dot no light equals true. Dust2 dot scale equals 0.5f. Dust2 dot no gravity equals true. Dust2 dot custom data equals this. If main.rand.next 4 equals 0, so every 1 in 4 will fall to the ground. So that's pretty much all the AI. Let's go back over into here for a final build and reload. And that's not the right weapon. As you can see, we're spinning it around. You can see the dust particles flying around. Let me set it to night. As you can see, they're going around like this. And they'll also switch direction. And here is the weapon in effect. So yeah, let's close that. I will just switch over to here. Move that down like that. So the two graphics I have are the spinning weapon. As you can see here, it just looks like this. This is what appears in the inventory, and yes, this is just two of the I want to say mithril or adamantite. I can't actually remember what one this is. Just reversed. It's an axe. And I've basically just used that as the projectile as well, so they're both exactly the same graphic. So yeah, there we have our spinning weapon. You can try changing the values of stuff. You can change dust values if you want. You can have your own dust code. This is all pretty much important. You can change the lighting. This is the red, green and blue value, either between 0 and 1. So that's if you want to get the correct value, you do 1 divided by, I think it's, let me just bring up a calculator. 1 divided by 255. Hang on, I need to bring up the scientific calculator. 1 divided by 255 multiplied by the R value. So if, let's say, our R value is 200, then our float value would be 0.78, and that would be the equivalent of 200 R. So let me write that as a little note. To get RGB value, do 1 divided by 255 multiplied by value, where value is equal to the RG or B value. Let me change this to get RGB float. Do 1 divided by 255 multiplied by value. So there we go. That's our spinning weapon complete. All this code will be up on GitHub. You can freely copy and paste this. This is, again, adapted from the Skydragon's Fury. I haven't written this myself. This was based on Terraria's code, so some of the stuff can be confusing. And I've tried naming the variables as well as I can, but some have been a bit difficult than others, such as anywhere there's a num. I think this might actually be half the size of your projectile. Not 100% sure on that. But yeah, thank you everyone for watching. Hopefully you enjoy the bloopers. Until next time, goodbye.